So this is my slides basically. So PosturePal, that's the name of the like
Mm-hmm.
model. PosturePal, AI powered yoga posture correction. So it's revolutionized yoga practice through intelligent computer vision and real time feedback.
Got it.
Yeah. So here's the reason why posture correction matters. This is basically my problem, like the
Yeah,
problem, which
understood.
yeah, yeah.
Yeah.
So yoga offers incredible benefits for body and mind, but improper alignment can lead to serious injuries and diminished effects, right?
Mhm.
So beginners often struggle with like posture and even like people who done yoga for a long time, they can develop like bad habits for their posture. And
Mhm.
basically what posture pal does is basically it bridges this gap of like bad posture. It doesn't matter if it's a beginner, experienced person. It bridges this gap by delivering precise, automated corrections that make yoga like safer, more accessible to everyone, regardless location and experience level.
Understood.
And so like Posture Pal, like here's the like actual like benefits it can do. It can provide injury prevention. Um, and many practitioners like lack real-time expert guidance, right? But PosturePal can actually provide that for you. And then AI solution, like instant personalized feedback powered by computer vision, right?
Under, understood.
And then here's some project goals and core capabilities. Um, our mission is to combine advanced pose classification with intelligent feedback generation, making expert yoga guidance available to practitioners anywhere, anytime.
Mm-hmm.
So what we want to do is we want to detect the poses and then we want to like evaluate them, right? We want to correct them if they're good or they're bad. And then we're going
Mm-hmm.
to give them feedback. We're going to deliver clear, specific recommendations to help users adjust their posture.
Got it.
Now, building the foundation. So basically, our data set it comprises of different, like 40 different yoga poses, and
Mm-hmm.
within those yoga poses, like each yoga pose has like a folder filled with a bunch of images, and in total we have like 2.7 thousand images, around that much, and we have 33 body landmarks, which is precise tracking points extracted per image.
Understood.
And the data set encompasses real world variety, different
Mm-hmm.
lighting conditions, backgrounds, camera angles, body types, all of that. This diversity ensures our model generalizes well across different environments and users, from home studios to outdoor settings. So basically, it can be used to identify stuff like anywhere at any time. That's why we're using so many images and so many poses.
Understood.
Um, Pose landmark extraction with media pipe. So we use media pipe for our landmark extraction, and it serves as our computer vision foundation, right?
Mm-hmm.
It's detecting 33 precise landmarks across the body. Each landmark captures four critical dimensions: X and Y coordinates for position, Z for depth, and a visibility score indicating detection confidence. Detection
Got,
confidence, like how close the pose is to a good posture. So basically,
understood.
landmark detention, coordinate capture, and normalization. And the last step, like normalization, is crucial. It allows our model to recognize poses regardless of where the person stands in the frame or their distance from the camera, making like our model like really reliable and robust.
Uh, Got it.
And then feature engineering, geometry of poses. So raw landmarks are transformed into meaningful geometric features that capture the essence of each pose. We compute joint angles at critical points like knees, elbows, and shoulders, along with distances between key body landmarks. Landmarks are basically like certain positions used for, as I explained earlier. This engineering process distills complex spatial data into a compact pose signature. 74 carefully selected features that mathematically describe body configuration. These features become the input for our classification model.
Got it.
And here's just a summary: joint angles, distance metrics, and pose signature.
Understood.
And here's our our model performance. So for the test accuracy, we got strong classification performance across 40 plus post categories is 86.85%. And for classes, like I already told you, like we have 40 plus. And then features, 74. And our random forest classifier achieves impressive accuracy in identifying yoga poses from geometric features. Labels are systematically encoded using label encoder, enabling efficient training and prediction. This high accuracy forms the first critical step, um, from the critical first step, correctly identifying the pose before we can evaluate its execution quality, right? And then evaluating posture correctness. This is the um one of the final steps. Not the final step, but um yeah, it's a big step. So basically after identifying the pose, PosturePal applies rule-based evaluation, comparing measured angles against optimal ranges, like using those landmarks you provided earlier. And then the system generates an overall correctness score and identifies specific areas needing adjustment. Like, for example, bending your left knee more or straightening your back, stuff like that. And then that guides users towards safer, more effective practice.
Got it.
Then real-time user experience with Streamlit. So basically, this app was, this like model was built with Streamlit, right, for rapid deployment because Streamlit is like fast, user-friendly, cross-platform compatible. It's accessible from any device with a web browser, right?
Mm-hmm.
I say this, but the thing is, while we were like trying to deploy this on Streamlit, the thing apparently like crashed or something. It didn't work
Okay.
the first time. But I
Well,
think that one of my teammates, Sam, I think she got it done with Streamlit. I don't know. But as far as me, I couldn't like do anything with Streamlit because it wasn't like working.
okay. Okay.
And then future roadmap and conclusion. So we're gonna expand our data set. We're
Mm-hmm.
gonna integrate like a live webcam. So
Understood.
instead of just inputting images, we're gonna have like webcam if you want that. And then
That
we're
would
gonna have uh, yeah, and then we're gonna have probabilistic scoring, and then in the future we're gonna have mobile deployment.
okay.
So
Got it.
yeah,
All
I think
right.
that's it.
Nicely presented. This was nicely presented. Done. Have a demonstration ready with you?